Hi, humans. Today we are looking for the root of the problem. That's a
And
pun.
and puppies. Hello to puppies too. That is a pun. The root of the problem. We're
All
talking about
right.
trees, right?
Yes, definitely.
Okay.
So we've got a warm up here. I'm going to make one minor tweak to this. Instead of x plus 2, that quantity squared, I'm going to write this as x plus 2 times x plus 2, just as a brief hint for how you might solve that. Mr. Butterworth's also going to move this over slightly so that we can actually read the problems. And then I will move, oh, I can't move my stuff.
This is fine. The other option was for you to do the top ones and not know what they are, but I thought we should just.
That's fine. All right, so we're going to have you pause the video now. We've been doing a lot of distributing and double distributing. We want you to give that a shot before we go through the answers.
So they should pause.
They should pause. Have you paused
Okay.
yet?
And now we're going to write down the answers?
Now we're going to write down the answers. I'll start from the bottom, you start from the top.
Okay.
You're a jerk. I like that I had the only one that I actually had to do the calculation for.
That's why I wrote the plus 12. I was trying to help you out.
You are the worst. I'm going to finish cleaning that up so that our students can actually see what number that is.
I was trying to be helpful. You just didn't see my help in time. I apologize.
All right.
So our learning goals here are, it says to factor, complete the square, use the quadratic formula, and solve systems. Full disclosure, we're just even crossing the bottom one out. We're not solving systems. The other ones we're going to go through and talk about, but we will assess you on them, but we're going to give you some supports in those assessments. So you're not going to have to do these kind of with no information and just memorize all these pieces. So if you get terrified in this video, keep breathing. We will explain to you how we will support you on the spirals or quizzes or whatever we're calling these things this year.
All right. So I like that we said that and then immediately are going to two that we're going to solve out fully and I think are reasonable to kind of work through. So the goal here is to get x by itself, just like we've been doing with linear equations, but now we have to get some kind of fancy thing like we're going to do C and D for you and then ask you to take a look at A and B on your own. So I'm trying to get this x minus 1 that's stuck inside the squared by itself. And to do that, I'm going to kind of pretend that it's just not there for a second. I'm going to make this a box and color in the box so I can't even see what's there for a second.
So you're saying this is kind of like the equation 3x equals 48.
Yeah.
Because is that squared part of your box? Like, is that cross?
It was not, but it can be. That's easy enough to make the math box more welcoming. So we've got 3 times box equals 48. We know how to deal with that. We know we're going to divide both sides by 3, and that gets us 16 equals box. Now I'm going to see what's in my box. And I'm going to erase that, just like magic. And we've got x minus 1. That's always really satisfying with the things falling down when you erase stuff.
Oh yeah, I love erasing. I think at some point I want to just fill a page with stuff and then just erase it all because I think that would really feel good inside.
And we have to talk about how we undo something that's squared, and we already kind of know this.
Could I still think of this as a different box?
Sure. That might be really helpful.
I'm still scared.
So if I've got stuff squared equals 16, we can either think about this mentally or by undoing a square. And I think that might be the best thing for us to do because we know how to undo something that's squared. Ooh, shroots. That's right. We're taking shroots.
Yeah, exactly. Square roots. See?
Oh, square root will undo a square. And we have to take the square root of both sides. And one of the things we got to be a little bit careful of is that when we think about things that you multiply by themselves to get 16, we end up with 2 different possibilities. We got 4 times 4 is 16. So one answer is going to be 4 is equal to our box. And then the other one we are going to have is -4 times -4 is equal to 16. So one of the things we can do is write -4 is equal to the box. Mathematically, I don't actually like writing things this way, but I'm okay going with this today because understanding where that comes from is not that important for me right now, as long as we're kind of able to get to this place where now instead of these boxes, we've got x minus 1 is equal to 4 and x minus 1 is equal to -4.
I was going to write stuff for you, but you just kept going. It's fine. So now can we solve these?
I think we can. Hopefully we can do x equals 5 pretty quick by adding 1 to both sides, and then x equals -3 by adding 1 to both sides again.
Now,
These are
if I really liked the graph stuff that we did in the last section, where do these show up on my graph?
on a graph, and right now graphing this is kind of a weird thing because we don't have a y equals.
No, I was thinking if we thought of it like this, not with an eraser, 3x minus 1 squared minus 48. So if I subtracted the 48 over,
And then put a
because
y.
that's a form I know.
But we also have this weird thing where there was a number there. The number was 0 before you put the y in.
Oh, so y is 0?
Okay, so, and we know when y is 0, that's like the x-intercepts.
Oh.
So these numbers, 5 and -3, would be the x-intercepts for this graph.
Not to scale.
Not to scale.
And since this is a parabola, the vertex is at 1, -48, which is somewhere down here. And it look, this is hard to draw because you drew it so not to scale. It'll look something like that. But so
my graph is perfect.
we're finding where this curve, were it to exist, would hit the x-axis.
I like it.
Sweet. So for the next one, you're saying I should do like the same thing. I should think of it as 1/2 times some sort of splotch minus 18 equals 0. I drew a splotch in, I swear, but it didn't show up. But I'm just going to keep going.
It showed up here. That's weird.
Oh, interesting. Well, it's not on the video, but maybe it will.
I think it will show up in a minute.
That'll be exciting. So to take care of that 18, I'm going to add 18 to both sides. So I'm going to 1/2 the splotch equals 18. And again, children, I swear I am writing right now.
There you go.
And it will show up maybe in magic. Oh, that one showed up. Now the next part has to show up. But I have 1/2 of the splotch equals 18. In order to get rid of the 1/2, I'm going to have to multiply both sides by 2. I like how this worked for you, but not for me. And so I'm going to have the splotch equals 18 times 2, which is 36. And
hey,
still hasn't caught up, but we're getting closer. Now I'm going to have, so I have 1/2 the splotch equals 18. I already did this part, but maybe I should just keep talking and let it catch up. I don't know what's going on right now.
He's also going to switch pages in a minute, so.
Oh, splendid. This part of the video is just going to be awesome.
Maybe we pause our recording for a second. Oh, no, I think it's catching up faster now.
We might be good. I stopped writing, so we'll see. So I need to figure out what the splotch is, and it was x plus 5 squared.
Mm-hmm.
And so I now write, but I don't like the x plus 5 because that's scary. So I'm going to write a different little doodad there. Squared equals 36.
So red splotch squared is 36.
Yeah. So just like you said, I'm going to now unsquare things or square root things. And we're going to write them as two different things because that's what you did. So I'll have the splotch equals 36, and the splotch is x plus 5. Not 36. What's going on in there? 6, or the splotch, which is x plus 5, equals -6. For both those, we're going to subtract 5 from both sides, so we'll get 1 and -11. I'm going to do a quick recap of what just happened because the video got a little crazy. So let me recap. So at the beginning, in the beginning, I made this whole little expression, x plus 5 squared, I made it go away because it was too scary for me to deal with. I then added 18 to both sides and multiplied by 2. So I got the splotch all by itself was 36. I then looked at what the splotch was and turned it into a different splotch and said different splotch squared is 36. took the square root of both sides and got 6 and -6, and said, oh, that means x plus 5 is 6 or x plus 5 is -6. And then we subtract 5 from both sides. So I figured out that my answer here is 1 and -11.
That was an excellent recap, Mr. Butterworth.
Thank you. Now their job is to do A and B.
Oh, so the stuff that I was just animating, that's space for them to do those problems.
Yes, or they can do a separate piece of paper.
That's fair.
YOLO.
All right, so here we've got Oscar. And I think we should probably talk about this. I was going to say the students should look at this one, but Oscar did something that we don't necessarily know real well how to do yet.
I think the students might understand the first 3 pieces.
I would agree. So you're saying like we're okay, pen, here, here, and here.
Yeah, because they have the original equation, subtracted 27 from both sides, and then combine like terms.
So I'm kind of confused at what's going on here. What if I tried multiplying this out just to see what it is?
Oh, that double distribution thing? I'm getting good at that.
So we got x squared, 6x minus 6x minus 36. Oh, and I got some like terms. Plus 6 minus 6. Oh, that's cool. That goes away. X squared minus 36.
That's where it came from.
Oh, so it's like they did double distribution but backwards to get the original parentheses that would have been there.
Yes.
Okay.
That has a fancy F name.
It does. It rhymes with something that everybody likes to mow lawns with. I was trying to find a fancy way to say tractor and I failed.
I thought you were going to go with tractor, but I didn't know where you were going to go with this the start of your statement. Tractor. It does rhyme with tractor. But anyway, once we have done that tractoring, which is really called factoring, we now have 2 things multiplied together and we get 0. And the only way we can multiply things and get 0 is if one or the other is 0. So then we write each piece equal to 0.
Oh, so like if the first piece is equal to 0, the second piece can be anything, doesn't matter.
Correct.
And if the second piece is equal to 0,
would be 12.
Then the first piece could be anything, doesn't matter. And
True.
And that would be -12 based on these numbers.
Yes.
And those are pretty easy equations once we get from here to there.
Yeah, and they may be okay with this if they think graphically. So this is like factored form of a quadratic. And so if you connect it to what we've been doing with all our pictures in the last section, it hits the x-axis at 6 and -6. So you may be okay with that. We'll see.
So it's going to look something like this.
Yes, and we know it's an up parabola because there's a 1 in front of the x squared.
Cool. And are we okay saying this is going to be -36?
I'm okay with that. I don't know if they are.
I bet that'd be a great question. If you're confused, maybe ask that in class.
I concur.
All right. So this is what Oscar was doing, the thing that rhymes with tractoring. And we mentioned that we are going to, when you're asked to do something like this, you're going to have supports. So it's okay if this is a little bit confusing, or if you are kind of following stuff, but you would be afraid you wouldn't be able to do that on your own. So there's a worked example here, and they do something weird at the beginning. That's what question, I can't read the number, is asking.
I'm going to guess 1.
Or maybe it's A. It's a 1. Oof. So I look at this and I notice that they are adding a 3 to both sides, and they get 0 by itself on the right side. I also notice that looks kind of like what we did in the previous page. I think that might be kind of a big deal, because you said if you have 2 different things that multiply and get 0, either A equals 0 or B equals 0.
That's what the 0 product property is saying right there. That's what the remember is.
Oh, remember.
That's exactly what you're saying is right there. And then I was moving around the other piece, the think about, because we just talked about that. What is the connection between the worked example and determining the roots in factored form? So the roots that we found 3, and 1 come from the factored form, which we've been talking about graphically.
We have. As far as the how to get from one to the other, I don't think we're going to talk about that right now, unless I am incorrect in saying that, Mr. Butterworth.
No, I think I concur with your assessment. We'll touch on it, but we'll probably also create a separate
Yeah.
video going more in detail of that.
All right. So we've got two students, Angela and Dwight. I wonder where those names came from, that both solve this incorrectly.
They come from The Office.
Oh, I like it.
It's a good thing you said that. Otherwise, I wouldn't have thought about it.
I wonder if other names have been from pop culture things that we didn't recognize.
We are old people, so
It's
probably.
true. So here they're talking about some errors, and what I'm really interested in is not the error in the factoring step, which in both cases they did the factoring okay. And again, we're not worried about that right now.
So you're talking about the two parts that I'm outlining in blue here. Those are actually good mathematical steps in terms of how they did them.
The other thing that I notice is that both of the ones that we've seen with factoring so far don't have a number there.
Well, they have a number there.
That's true. They don't have a number that we often consider having a value, even though it does. In fact, I kind of put that number there accidentally when I was circling things, because when we're solving with a method of factoring, we really need that other side to be zero. And they
Because
both
that
did the
zero
same thing.
product property thing.
Yeah, that's a really big deal. So a first step for Angela that would have been really good would have been writing this as x squared plus 6x, and then if I minus 7 to both sides, there are no like terms there, so that's going to go on its own, and that's equal to 0. This is going to factor into two things that we're going to distribute. It would end up factoring into x minus 1 and x plus 7. And then from here, we have two things that we're multiplying together, and the answer is 0. That means either x minus 1 is 0, which would mean x equals 1, or x plus 7 is equal to 0, which means x equals negative 7. Mr. Butterworth, was that a reasonable, we didn't explain the factoring part. I think that's okay for now.
Yes, I agree. And similarly for Dwight, he wants a 0 there. So subtract 6 from both sides, so have x squared plus 5x. In this factoring they may be more comfortable with. You factor an x out. It's called the greatest common factor.
It looks like you're creating a distribution problem. Could we call this undistributing?
Yes, factoring is the same thing as undistributing. And then just like Mr. Carlson said, either x equals 0, in which case I'm done, or x plus 5 equals 0, which means x equals negative 5.
Cool.
So this is the same, like this is going to be factoring, and we can show you what things would turn into. But again, we're not going to go through too much of the why. We're going to do a separate video of that for you. So the first one, it's going to factor into x minus 6. This is always good to be talking and factoring in your head at the same time. What could possibly go wrong?
That's
so
true.
X minus 6 equals 0, which means x equals 6. Or x minus 2 equals 0, x equals 2.
For the second one, I noticed that we're set up in kind of the same way that Dwight and Angela were, where we have to do some work first. I want the negative 7 to become a 0. So I'm going to rewrite this so that we're kind of lined up. And to do that, I'm going to add, what I forgot next. I'm going to add 7 to both sides. So x squared, I got to be real careful not to add the 8x and the 7, even though I kind of stacked them because I ran out of room.
That's my fault. Apologies.
You're the worst. Well, you're also using a stylus, and that makes it harder to write tiny.
It's true.
And then factoring this, we'd end up with x plus 7 and x plus 1. And we know that either of these two things have to multiply together to get 0, so one of those has to be 0. either x plus 7 is 0, so x equals negative 7, or x plus 1 equals 0, or an x equals negative 1.
Same idea for the next one. You just take out the greatest common factor, which I'm just going to take an x out
I think that's fair.
and have 2/3 x minus 5/6. I'm hesitating because there's fractions there, and I know not only are we talking about factoring, but there are fractions. So either x equals 0, in which case we're done, or 2/3 x minus 5/6 equals 0.
Hey,
Now,
could we make that less gross and multiply by a big number to try to get rid of the denominators? Or do
by
you,
a big number, do you mean 6?
I do.
Sure. So if I multiply everything by 6,
Can I
the
do the
right
hard
side,
part? 6 times, oh, you beat me to it.
I was obviously that's the math teacher move. I did that to get my calculus kids the other day. It was a good time. But 5/6 times 6 is 5. And
Yep.
then 2/3, so 2/3, I'm going to do it in Mr. Carlson's work over here, times 6 over 1. I would do what I think Mr. Carlson calls cross canceling. Is that what you
Mhm.
call it? Cancel that way. And then that's 2 times 2, which is just 4. If you don't believe me, you should. So 4x minus 5. And by the way, if someone ever says, just believe me, don't. Add 5 to both sides. And then x equals 5/4. I almost said
There we
4.
go.
That was a close one. Woo.
The last one, I actually have a little bit of trouble with the way that this is written because it says to solve each quadratic equation if possible. And maybe that's the answer. We can't
I think
solve
that's
this,
the
right?
point. I think it's saying you can't do that because where there's no 0 there. You could find the roots of that, but you can't
Um,
really solve that.
yeah, I mean, we could set that equal to 0 and then solve, but with that not being 0, we can't actually solve that yet. I think
Right.
we're good leaving that there.
So the next page has
Oh,
Jim and Pam continuing the office theme. I love this. I didn't realize this. This is super exciting.
and this time both of them did stuff that was right. Um,
How do you know that?
because there are some thumbs up here.
Oh, I should pay attention to those.
The what I like, so I noticed that like Jim's strategy, he did the stuff we did the first time where he added stuff and got. So this was like the splotch method, I'm going to call it, uh, where we have to get the splotch by itself and then put things back in. Although in this case it's just an X, so it's not a scary splotch. Um, and in doing the square root part, the thing that that's a plus or minus symbol. That's something that's new for us. All that means is that x equals the positive version of the square root of 25 over 4, and x equals the negative version of the square root of 25 over 4.
And so when we did this before, we wrote that as 2 equations. Is that okay to do?
It is, and it's also okay to write this as plus or minus. Either way is okay. This is a shorter way so you don't have to repeat writing things.
But it's also one of the most commonly forgotten things that our
It
students
is. In fact, that may be the most commonly forgotten thing of the stuff that we do this year.
That's probably true. And then Pam does the same idea of what we were just talking about. She factors, which again, we're not getting into too much. If you don't believe that she's right, if you multiply that out using double distribution, you'll get the 4x squared minus 25. But then once she factors, she sets each piece equal to 0 and solves.
All right, and now there's a third way to solve quadratics. This is something called completing the square.
I love completing the square.
I do too. And again, this is something that we're not really going to go obsessively into. The big idea is that if you have something that's a splotch squared equals a number, you can square root both sides and make that not too bad to solve.
Which is the middle part of the page right there. When they turn it into something squared equals a number, you can take the square root of both sides, and life is way easier. Although I'm a little bothered that that square root doesn't go all the way, so I'm going to go ahead and
There you go.
extend that square root. The stuff above, so part of the reason I like completing the square is because it uses solving quadratics by square roots, and it uses factoring together. So I enjoy that. You notice that this is equal to 0, but they said, no, we're not equal to 0. And that might be the other part of the, because this was the example they had on the previous page. There was no way to
Mm.
actually factor that problem. So that might have been also what they were trying to
Oh,
get.
that's fair.
But So what they want to do is they want to turn the left side into something nice that I can write as one compact splotch squared. So they get it to x plus 5 squared. How they do that is by making a connection between the 10 and the number out here, which some of you may instantly see the connection between 10 and 25. Hint, it might involve the number 5. If you don't, that's okay. But they added 25 to both sides to get a nice thing that they could then factor. So the step from above my rectangle into my rectangle is a factoring step. And then they use square roots to solve it. So look through this. We'll talk a little bit about it in class and we'll play with it a little bit. But don't freak out because there's a lot there, but don't freak
There
out.
is. And I feel like that's kind of maybe the theme of this video is don't freak out. There's a lot. This is a lot of stuff. But you're going to have support to be able to use some of these strategies. All right. What do you say that do we want to do both of these or just choose
I
one
think
to
if we
start
do
with?
one, it's fine because they're basically the same.
I'll do the one on the right because that's where my hand is.
That sounds good.
So I'm going to do the same thing they did on the previous page and get rid of what I think about is the C term uh, by minusing that to both sides.
On the previous page, they said isolate x squared plus 10x. So Mr. Carlson is isolating x squared minus 12x. You forgot the x, but he'll probably put it there in a minute.
That's true. I also left some space there because I like thinking about this as I know something is going to go there, but I don't know what it is yet.
And so this harkens back to when I said you might realize a relationship between the 10 and the 25 and gave you a hint of the number 5.
So here I've got, instead of a 10, I've got a negative 12. And if 10 gave me 5, you might think that you're cutting that in half, and literally that's what you're doing. So here we're thinking about this as negative 12 is going to give us negative 6. And if we went from 5 to 25, that was by squaring. I'm going to square that negative 6, and that's going to give me a 36. That's the magic number that would make this what we call a perfect square. Then we get our factoring step. Oop, I forgot to add to both sides. I was about to.
And it says add this term to both sides of the equation on the previous page.
Oof.
So that's what Mr. Carlson is doing now. And then he'll simplify the right side and factor the left. And in this case, we are factoring even though the right side is not equal to 0. Because when we factor, it turns into, you see how Mr. Carlson just wrote down 2 of the same? That's a helpful step. He also is now going to write it as a squared. Beautiful.
All right, and we know how to undo splotch squared. We're kind of stuck using the word splotch for the rest of our lives. You know that, right?
Yep, you are welcome.
And we know that's going to be x minus 6 is equal to, oh, that doesn't come out nice. I'm going to be lazy. I'm just going to write that as the square root of 30. And then I'm going to do the same thing. X minus 6 equals the negative square root of 30.
Can the students be lazy like that?
Absolutely.
Okay.
I would usually prefer that because this is a decimal. This is easier for me to see what you were thinking than having a decimal answer. And then I've got one last step, which is to add 6 to both sides. And I don't feel like adding those weird numbers together. So I'm going to write this as 6 plus the square root of 30. And it's okay for your students to do that as well. In fact, I strongly encourage it because you can't actually combine those terms. Those are not like terms. And then the other one is going to be x equals 6 minus the square root of 30. Since we have both the positive and negative version of this, we often write this as 6 plus or minus the square root of 30. These mean the same thing, both of these pieces with this piece.
So is it fair to say that the students will be assessed on this by probably more likely analyzing what other people have done?
I think that's a fair assessment. I like that you're just making that up on the fly, but that's a good idea.
Right, but I made it
Yeah.
on a video, so it's got to be true.
There you go.
So you don't have to memorize every step here. If we had more time and all that stuff, we'd play with it, we'd get you used to it and that sort of thing. We just don't have that. So what we're going to do is we're going to assess you on your ability to understand the steps people are taking. So we might even give you like this as an assessment question and say, in order to get from the red to the green, what did Mr. Carlson have to do?
I like it.
That sort of thing would be an appropriate thing. I'm trying to lower the anxiety of those students watching this
Yeah.
video now by giving you an idea of what we're going to be assessing.
And I'm assuming that there'd be some resources that students could have to help them even guide them through that.
Yes.
So that it's even less anxiety, I hope. All right. We've got a ball thrown up into the air.
And I think this one I want them to try.
I think that's fair.
Because if they think graphically,
Yeah.
they should be able to figure out what this curve looks like. And as long as they can connect the maximum height to concepts we've talked about previously, you should be able to do it. So you should try this one. And if you get stuck on it, maybe I should say when you get stuck on it, come talk to us about it in class.
Is there any kind of graphing technology that could help them with this?
Desmos is a good idea. But they also have an algebraic way to do it because they know a shortcut.
It's true. We do know a shortcut to get what if you can figure out what this is asking.
But try it out.
Ooh, we've got Jesse fencing a rectangular plot. Now I understand why we have that link there, because that's where that picture came from.
I like
I,
to
th
cite my sources.
I thought for a minute that was like a link to more examples. So we've got 60 feet of fencing. Um, would it be helpful, do you think, Mr. Butterworth, for us to maybe help set up the diagram and try to, again, have our students maybe think about this graphically to try to get to an answer?
Yeah, I think that's fair. I think so. We have 60 feet of fencing. So if I call, oops, that's not on the pen. If I call this X here, and this is a rectangle, so hopefully that side is X also.
So this whole thing is going to be 60.
Yes.
What if I want to know this piece?
Well, so if the whole thing is 60 and I've already used two X's, then that piece has got to be 60 minus 2X.
Oh, okay. So just to so we got 60 feet defense total. We know that each piece on the sides is going to be X. So we take both of those pieces away, and that leaves 60 minus 2X.
Mm-hmm.
And then we're also talking about a maximum area. So if we had an equation for area, that would be helpful. But what on earth is the equation for the area of a rectangle?
Why, of course, it is base times height.
Oh, okay. So if this is our base, so my area equals my base, I'm going to put this in parentheses, 60 minus 2x, and this is going to be our height times x. So that would be
Now,
like an area equation for us.
yes. Now, savvy students, if you're thinking, and if you're thinking about what we did in our last section, you recognize that form, you can now find two pieces of information, which
Mm.
means you can find a third piece of information and you can answer this question.
What if we didn't recognize the form this is in and we wanted to do this thinking another way? Would that be okay too?
Of course.
I feel like this one might be kind of similar to the last problem that we did as well.
Yes. Same idea. You'll notice minimums and maximum. We'll talk about them a little bit here. If you really want to get into minimizing and maximizing situations, you go to calculus land.
It's true. Did you find the typo in this problem? That's too much time. There are two different Jessies. One is Jesse
Oh,
IE, one
Jesse
is
and
Jesse
Jesse.
with E.
I hope the students were reading along with me. I wasn't quite at the next Jesse yet.
I realized that would take, although now we spent like 30 seconds on the typo, so I'm just going to press forward.
That sounds good.
Okay. And both of us are just having like an oh boy moment because we have a fourth way of solving quadratics, which is using something called the quadratic formula, which is really completing the square, what we just did, but done in a very general way so that you can just plug numbers in. It at the same time takes away all of the thinking and is really hard because you accidentally lose negatives all the time, and it's really easy to lose track of something. It's the reason that Mr. Butterworth and I really don't like this as a method.
But it is used in a number of places, so we want you to understand what is going on. A lot of people like the quadratic formula because it's just a thing to plug in, and if you're programming like a calculator or computer, it is a way to program a calculator or computer
Sure.
to solve a quadratic. So it is useful for that. I
Um,
agree that the beautiful math that is done in completing the square, which actually also involves vertex form, we didn't mention that.
it's true.
It all disappears here, but it's okay. So how they're doing this is they set the whole thing equal to 0 because again, this is finding zeros or roots of the quadratic. They determine the values of a, b, and c. So think back to standard form. Standard form was ax squared, or a squared if you're, me and writing the wrong thing, ax squared plus bx plus c. So that's standard form. Well, I guess they have y equals or whatever. So a in this case is -4, b in this case is -40, c in this case is -99. The quadratic formula is nice in terms of you can take really ugly numbers and put them into the quadratic formula. But if you look at the answers to this problem, I would have just factored it because they're going to turn out nicely. But that's just me. I'm a crazy person. I know
True.
that.
Cray cray like Tay Tay.
That's right. But so all they do is they use this crazy formula up here and they plug numbers in. So they said they said B was -40. So up here it says opposite of B. So they put the opposite of B. And then they had B squared minus 4AC and they plugged in B squared minus 4AC. And then down the bottom they have 2A. And then you do some calculations and simplification of numbers and combining like terms, and you got to two answers.
Um, to me, I think an equally useful method based on the technology that we have this year would be to take this, graph this in Desmos.
And by this, do you mean y equals this?
Yes, thank you. Although if you put 0 equals, it might actually give you the answers. It does that for equations. I don't know if it'll give you two answers at once, though.
It may give you vertical lines. I don't remember.
So if you were to graph this as y equals in Desmos, if you find the x-intercepts or the zeros or the roots, hey, this is the root of the problem. Those are going to be the same answers that we got down below. And especially in a year where we're so technology dependent, that makes a lot more sense to me as far as you understanding the math than using this formula, to be entirely honest. And I'm assuming that Butterworth agrees with me. Um,
I
it's
do.
also much less scary. And this is a really scary looking thing, to be entirely honest.
But we're still going to talk you through on the next page when Mr. Carlson has us go to the next page. We have the Seaside Serpents baseball team has a new promotional activity to encourage fans to attend games, launching free t-shirts because everyone loves a t-shirt launcher. So they can launch a t-shirt. They have initial velocity. They have a height. And then they wrote this equation, which you may notice this. Oh, that's not the pen tool. You may notice this equation here. The -16t squared already showed up in a question earlier. And then you may see that the 91 is the 91 of the initial velocity and the 5.5 is the 5.5 at the end. There are some physics components to this question. We completely ignore like air resistance and stuff like that, but that's okay.
And not shooting this straight up and down, but that's not, yep.
Right, but
Yep,
we simplify life. Yes, we don't deal with angles.
it's like the male bees that were having children on their own.
Yes, I was very confused, but I'm good. So why does it make sense to use the quadratic formula? Because the numbers are kind of funky. You have a 5.5 there, you have a 91, you have a -16. So since you have crazy numbers, sure, use the quadratic formula. We're not going to use the quadratic formula, but you are welcome to use Desmos and figure out the answer to this. It is important and helpful and useful before you even use Desmos to ask yourself, what would a sketch of this look like? Because you should be able to figure that out.
And I'll give you a hint. There's a picture of this already on this page by accident.
You're the best, Mr. Carlson.
Oh, I know.
And then our last thing we're going to talk about, don't worry, we're almost done. We believe in you. So we need to figure out what Meredith's error is. So Meredith has an error because
Okay.
so Meredith has x squared minus 7x minus 8 equals 3. So she said, okay, x is 1. Is this still from The Office?
Yep.
But was there a Jesse? I don't know the answer to that. So students, let us know because
Yeah,
I don't remember. But Meredith said x is one, a is 1, b is -7, c is -8. So I already know what her error is.
I do too.
Because what do we need the equation equal to in order for us to solve this? We need the equation
Uh,
equal to
0.
0, and we don't have a 0
Oh,
there. We have a 3 because it's saying down the bottom the roots are this. So Meredith figured out where this equation, x squared minus 7x minus 8 equals 0, but that's not what the equation we're given is. The equation we're given is x squared minus 7x minus 11 equals 0. So Meredith found the answer to the wrong question. Beautiful work with the quadratic formula that Meredith did, but did not answer the question.
so you're saying that if we had moved the 3 to this side, we then could have used either the quadratic formula or use Desmos and graph this and find the zeros.
Yes, you could also use completing the square.
I feel like that might be kind of gross because that'll make a fraction.
Right, that would blow up their brains, but I'm saying you
Yeah,
could do it. You don't want to factor it because this doesn't factor, but you could do it.
cool.
I think we did it, Mr. Carlson, because everything else is like actually using the quadratic formula or some systems, which we're not going to talk about right now.
So if I wrote or Desmos,
Yes,
that would make these ones accessible for our students.
I agree.
And then there's some assignment stuff that I believe is in your Jamboard after this that we will probably have you do some things from instead of me pressing the next page.
That is true because it's not there right now, but it will be.
Oh, problems of future teachers.